In this lesson, we'll look at naming compounds with polyatomic ions. Now, polyatomic ion, as the name suggests, is a group of atoms that has a charge. So there are extra electrons or there are missing electrons within this group of atoms. We can learn how to draw these, and that's a different lesson. But today what we're going to do is look at ionic compounds that involve them. So a couple of examples here. We have ammonium ion, and you can see the formula is NH4+. So it's this group of atoms, one N and 4 hydrogens, and overall it's got a +1 charge. And we think of it as a little package of atoms that will stay together. Hydroxide is another example. And so if you draw the Lewis structure for hydroxide, this is what it looks like. This is how it's bonded and where the electrons are. But overall, we can think of it as a group of atoms joined together, carrying an overall charge. In your OneNote, you have a list of polyatomic ions. This is a short list of polyatomic ions. There are lots of other ones, but these are the ones that we'll be working with, and so you'll want to be referring to this table as we're doing examples. Now, when we're working with polyatomic ions, the naming and the formula writing is the same as with binary compounds. So when you want to write a formula, you're going to write the ions beside each other, the positive ion and the negative ion, and you're going to do the crossover method. So let's look at some examples. Ammonium chloride. So ammonium is one of our polyatomic ions, and it is NH4+. So I write that ion down. Chloride refers to chlorine, so I look at the periodic table. It's got 7 valence electrons, so it will have a charge of -1. When I join these two ions using the crisscross method, I get NH4Cl. So I need one positive ion and one negative ion to make the ionic compound ammonium chloride. In this next example, we've got sodium phosphate. So sodium is a metal. I can use its position on the periodic table to know its charge. It's got a charge of +1. Phosphate is a polyatomic ion, so I look at the list. Phosphate is PO4 3-. When I do the crossover method here, I know that I need 3 sodiums. So Na3PO4. Now looking at this example down here with calcium hydroxide, you can see that if you need more than one of a polyatomic ion, you're going to put it in brackets. So calcium is 2+ and hydroxide is -1. So when you do the crossover method, you know you need 2 of this whole package of atoms. And when you want 2 of them and you want to show that they're a group, you put them in brackets. For naming, it's the same as before. If you've got a multivalent metal, you need to show the charge. But if you've got something like lithium, which is always +1, you don't need to show the charge, so you just name the metal ion, which is lithium. We look at our list here. CO3 is carbonate, so this is lithium carbonate. In this last example here, we have nickel, and then we have ClO4. So I look at the list. ClO4 has a charge of -1, and that is chlorate. So I know that it's going to be nickel chlorate, but because nickel is a transition metal, I need to identify the charge. So just like I did with binary compounds, I'm going to do the reverse cross. So I'm going to bring the 3 up, and I know the charge on the nickel is +3. So ClO4-, so in brackets, I need to put the 3. So that concludes writing formulas and naming ionic compounds involving polyatomic ions.